All right, we are starting chapter 5, and this is correct. Your eyes are not deceiving you. We are starting with 5.2. We will come back to 5.1 after 5.3, but we're starting with 5.2, which is called proving lines are parallel. But before we get to that, we're going to start with this theorem. And it says the measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. So let's look at this picture over here. Here is our exterior angle out here, outside of the triangle. And notice it's adjacent to and next to this adjacent interior angle. Now, these two together equal 180. Remember that also the sum of the angles of a triangle equal 180. So actually, the blue angle, the exterior angle, is equal to the sum of both remote interior angles. So the theorem is saying that the exterior angle is greater than either remote interior angle, so either one of them. So that does make a lot of sense. And so basically it's saying that this exterior angle is greater than either remote interior angle. Now, what that might look like in an example is something that looks like this. So here we go. Let's make a triangle. And let's say in this triangle, we know this angle is x, and we know this exterior angle is 120 degrees. So what this theorem tells us is that we know that x has to be less than 120 degrees, but also it's not negative, right? So it would be greater, also, well, in between 0 and 120 degrees. We'll just say it that way. It has to be more than 0, but also less than 120 degrees. Another example might look like this. Let's say this angle out here had the x. Let's call it x plus 40. And this little angle here was 20 degrees. What we know is x plus 40 has to be greater than 20. But again, there's an upper limitation here of 180 degrees. This angle cannot be more than 180 degrees. And so that's what those constraints would look like for that. Now, on to the angle theorems. Now, remember, we did this long time ago before the break, but we learned that if we have parallel lines, or in other words, two lines with a transversal, we'll call this line L and line M, and remember this was our transversal. And I'm going to number the angles. 1, 2, 3, 4, 5, 6, 7, 8. So, if we have, what we know here is if alternate interior angles are congruent. So let's just remind ourselves, alternate interior angles. So that would be like 4 and 5, right? And then also 3 and 6. So if alternate interior angles are congruent, then the lines are parallel. So we would have L parallel to M. You know what? Let's write it this way. I should have wrote it this way. Let's do it this way. So let's say angle 3 congruent to angle 6, or angle 4 congruent to angle 5. If we have that, then the lines are parallel. Alternate exterior angles congruent. So alternate exterior, remember, would be like angle 1 congruent to angle 8, or angle 7 congruent to angle 2. If we have that, then the lines are parallel. Corresponding angles. Oh, these are so many. It's too many. Corresponding angles congruent. So that would be, I'm going to put them underneath. Angle 1 congruent to angle 5. Angle 2 congruent to angle 6. Angle 3 congruent to angle 7. And angle 4 congruent to angle 8. If you can show corresponding angles congruent, then the lines are parallel. So it's these different angle relationships. Two same side interior angles supplementary, then lines are parallel. So if we have, I'll do it over here, angle 3 plus angle 5 equals 180 degrees. Or in other words, angle 4 supplementary to angle 6, right? Supplementary or adding up to 180, then the lines are parallel. And then finally, I haven't used this color yet, two same side exterior angles supplementary, lines are parallel. So same thing or similar, angle 1, oops, not congruent, supplementary to angle 7, or angle 2 supplementary to angle 8. All right, so those are all those angle relationships are ways to prove that two lines are parallel. If you can just show one of those relationships, then you can say the lines are parallel. Very, very valuable. Next we have, if two coplanar lines are perpendicular to a third line, then they are parallel. So we have two coplanar lines. So in other words, let's write it this way. If A is perpendicular to C and B is perpendicular to C, then A is parallel to B. Okay, so if A and B are both perpendicular to a third line, C, then A must be parallel to B. Okay, so finally we have this proof. So it says a parallelogram is a four-sided figure with both pairs of opposite sides parallel. So that is the definition of a parallelogram. This is the definition. A parallelogram, now there will be a lot of properties of parallelograms that we're going to find out, but by definition, it has both pairs of opposite sides parallel. So that's what we need to prove. We need, if we're going to show that PQRS is a parallelogram, we need to show that QR is parallel to PS and that PQ is, parallel to RS. Okay, we have to show both pairs of sides, opposite sides parallel. Now, what we're given angle 1 congruent to angle 2, and we're given that this big angle is congruent to this big angle. Okay, so let's put that down here. So we have angle 1 congruent to angle 2, and we have angle PQR congruent to angle RSP. Okay, so remember, to show that two lines are parallel, we need to show one of those angle relationships. Well, notice angles 1 and angle 2 are made up of these three lines. 1, 2, 3, right? Those three lines make up angles 1 and 2. And so PQ and SR would be parallel, with QS being the transversal. So we can say PQ parallel to RS, and that is because alternate interior angles congruent means parallel lines. That's how we're going to write the reason. So we state the angle relationship, arrow indicates that they're parallel lines. Okay, so that was that, but now we need to show that QR and PS are congruent. And so I didn't mean that. So QR and PS would look like this, right? And the angles that we need to show are congruent now would be angles 3 and 4, right? Because those two parallel lines that we want to be parallel with the transversal make up angles 3 and 4. So we need to say 3 and 4 are congruent. We can't say them right now. We could say them right now. Yes, because we could say they're congruent because we have the big angles congruent. Angles 1 and 2 are congruent, so it's our old congruent angles minus congruent angles equal congruent angles, our subtraction property. Well, now that 3 and 4 are congruent, we can say that QR is parallel to PS, and same thing, alternate interior angles congruent, parallel lines. And so finally, now we can say that PQRS is a parallelogram, and that's by definition. We have a quadrilateral with both pairs of opposite sides parallel, then it's a parallelogram. Okay, now, just some notes. If we're not done with congruent triangles, so just note, if we were not given congruent angles, you may need to prove that the triangles are congruent, right? To get to those congruent angles. Just note, may need to use that in the future.